Hello everybody, welcome to our project. My name is Mostafa Mohamed and I will now introduce to you our project idea. Our project is a smart lock. This smart lock, we used some components. We used a keypad to enter a pin code. We used a sound sensor to detect the number of knocks. We used the FPGA board and we used the servo motor and its arm act as the lock. Our project is simply entering a correct pin code of 4 numbers and a sequence of knocks. If the 2 inputs are entered correctly, the servo motor arm will move, which means the servo motor will open. Otherwise, it will not open and it will be closed. And now we will talk about each separate component in the next few moments.
Hello, my name is Youssef Amin. I'm going to talk about the part of the sound sensor. I'm going to show how the sound sensor detects the number of knocks that we do. These 4 BCD segments. Okay, so these 2 are for the password I am currently entering, and this one is for the already saved one. So I'm now gonna enter these like 2 knocks. If I press enter here, it will be my saved one. So this one is for the incorrect and this decimal point is for the correct one. So if I press submit, it will going to be like true. Now if I hit one more knock, then submit, it will come back to incorrect. And there's a button or a switch to restart the mode, like that. But the already saved password is here. We use a clock to detect the number of knocks we made, and when we submit, we check if the password we already saved is equal to the current password. We set the correct decimal point to 1, else we set the incorrect to 1.
My name is Fahmi and I'm going to discuss the keypad, which is used to enter the password to the FPGA, and then being stored in the FPGA, it will compare it with the password that the user will enter while trying to unlock the lock.
We have 2 BCD segment displays, one for the counter that will count the number of digits as follows: 1, 2, 3, and 4. The pin is 4 digits, and one that enters that shows the last input. Now I'm going to enter a password so that I can store it in the FPGA. To store it, I will make this switch on and then reset.
The entity of the keypad recognizer uses a clock so that it doesn't mix up the stream of inputs. Here the entity encodes the input so that it outputs the corresponding digit according to the pressed button, and then it stores the input in a signal so that it can check the correctness of the input.
Hello everyone, my name is Tito. This here is the servo motor. This is our output. When the user enters a correct number of knocks and enters the correct pin at the keypad and then submits, the servo motor will open if it's closed, and if he enters or the user enters a wrong configuration of password and knocks, the servo motor will close.
In this code, we used a technique called the pulse width modulation (PWM). Using the clock signal entered to the entity, we use a clock divider using the signal count to generate a 2 millisecond count interval to detect the entering signal and move the arm of the servo motor 90 degrees. Simulating the process of opening or closing.
Hello, my name is David. And as we have seen previously, we've seen each part working individually, but right now let's check the whole thing as one part. So now I'm gonna enter the default password and number of counts for the sound sensor, which should be, for example, 1, 2, 3, and an upwards arrow. And I'm gonna enter it. And for the sound sensor, 1, 2, and I'm gonna enter it. Okay, now I'm gonna submit it, and the servo motor, which acts as our output device, should open, which it did. Okay, now if we entered a wrong password, for example 1, 2, and we stop there, and I'm gonna submit it, the servo motor lock should close again, which it also did. So now we've learned that we need both the sound sensor and the keypad passwords to be working simultaneously together. If one of them would have entered a wrong password, the whole lock would close again, which was the main idea behind our project. So thanks everybody for listening, and I hope our project has been okay.